let him know.
The one really was not in the house.
Before they did, they were within the house.
He was the girl's back.
No, they were all in the
He's a great coach.
Good morning, Fayetteville High School. It is Tuesday, December 10th, 2024. Will you please join me for a minute of silence? Thank you very much. Please stand as you are able for the pledge. Flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you very much. Everyone, enjoy your day.
Okay, good morning, guys. There's a whole bunch of handouts I need you to get out of your binder. So for the second half of class, you will need number 60, 61, 63, and 66. I guess if you want to wait on all those, you can. But you do need to get out 65. 65 was the circuit we had started on last time, and we worked on it the first half of the class, but you did not need to finish it. I told you I'd give you more class time. So before I remind you what we're doing on 65 and give you time to do that, also I'll start checking some of your semester exam review pages, finish up checking the 61s for people who I didn't check off, all that kind of stuff, and then start checking 63s. I'll start doing that here in a few minutes once you guys get going. But I've been kind of dragging our feet here on the derivative of inverse trig functions, and this only takes a second to talk about, and you've seen these about 4 or 5 times, so I just want to formally tell you what they are, what you're on the hook for, and maybe some connections to help you learn those. So assignment 68 that you picked up on the way in today, there's no questions to be done. This is just informing you what the derivative of inverse trig functions are. So realistically, the only way to work these is to memorize them. In theory, I guess you could derive them if you remember enough about inverse functions, but nobody's trying to do that. The good news is, well, I went ahead and listed all 6 of them out here for you, because depending on how much calculus you're going to have to take, make myself a note so I wouldn't forget that again. Depending on how much calculus you have to take, you may need to know all 6 of these at some point. But for your AP exam, and this is where you should mark your page here, the only two that they ask on your AP exam, so the only two I would ever ask you, are the two that have been coming up occasionally, and I think both of these come up on the circuit as well. You probably just didn't get to those questions last time. The derivative of inverse tangent, not regular tangent, inverse tangent, is 1 over 1 plus x squared. Of course, there could be chain rule too. If this was a 2x, you would get this times 2 because it's a chain rule. And then the only other one they throw at you on the AP exam is the derivative of inverse sine. So you need to know those well enough that you can recognize them. And even though it sounds like I'm just talking about derivatives, this also works for integration. So like one of your circuit questions looks almost like this. So the answer is almost inverse tangent because you're integrating. So the other four won't come up for us. They won't come up on your AP exam. However, with about 10 seconds of work, you can come pretty close to knowing these, because if you memorize the derivative of inverse sine, inverse cosine is the exact same thing, except he is negative. The derivative of inverse tangent and inverse cotangent are exactly the same thing, except inverse cotangent is negative. And then the derivative of secant or inverse secant and inverse cosecant are the same, except the derivative of inverse cosecant is negative. So this is consistent with other derivative rules we talked about. When you take the derivative of something that starts with C, it's negative. Derivative of something that starts with C is negative. Derivative of something that starts with C is negative. Derivative of something that doesn't start with C is positive. So there's really only like 3 things in here, and the other 3 are just a negative version. So if you remember which ones are the negatives of which, it's not that hard to memorize all 6, but at the end of the day, for us, at the bare minimum, you need to know and recognize those 2. Okay, any questions about that? Okay, so again, then most of your time this morning will be asking you to try these circuit questions again. So I'd like to do just one more, just a refresh question. So I guess it would make sense, instead of me just picking one and maybe picking one that no one needed help with, let's just find the first question that someone had trouble with. So we did number 1 together, and okay, I shared a few answers. Looks like I shared answers up to question 5. So did anybody not get 15 as an answer on number 5 last time? Okay. Did anybody get stuck on question 6?
Yes.
Okay. Then 6 will be the one that I do as a quick little reteach. And if you don't have number 6 done, then you can just follow along with me here. Now, I did work this one for my other class yesterday, so this one looks a lot harder than it really is. It looks hard because of this number, but this stuff all kind of is rigged to where it all comes out very nicely in the end. Okay, so when we are doing antiderivatives / integration, same thing. We're trying to take a derivative and go backwards to the function. So the only 2 types of integration you need to be able, well, 3 types of integration you need to be able to do right now, is you need to be able to know that your calculator can do some types of integration. Sometimes you have a calculator to do it. You need to know how to undo power rule, which is what I'm about to do here. So raise the power by 1, divide by the new power, and 3, be able to undo the derivative of something you have memorized. We've memorized that the derivative of sine is cosine. So that's 3 of the 4 types of derivatives that you have to do for this class. Or I'm sorry, integration. 3 of the 4 types of integration. Knowing your calculator can do some, and sometimes it's needed. Undoing power rule like I did here, and undoing one I have memorized like here. the fourth and only other type of integration we even do in this entire class is something called U substitution, and we won't get to that till next semester. U substitution is a process to undo chain rule so that you're not having to undo chain rule in your head. Okay, but before I go forward here, I'm going to simplify this. 72 divided by 2 would be 36. Okay, and there could have been a constant, so you need to make a habit out of putting plus C. Obviously, when we get some more time, and as we get closer to your actual AP exam, we'll do lots of FRQ practice because those get easier the more practice we do. But just so you know, a lot of times you lose like 1 or 2 points if you forget to put the plus C. And it's 1 or 2 points out of 9 for each FRQ. So that's such an important calculus concept, they penalize it pretty heavily. But these particular questions, we can get a particular solution because they're telling us not only do we know his derivative, but we know a point on the function. So when y is 10, x is pi over 2. Oops. So everywhere there's an x, you should have put a pi over 2. Everywhere there's a y, you should have put a y, or 10. Bless you. And what this does is this gives you an equation that you can solve for c, and then we can go back up here and update this to have the specific function with not just some generic constant, but the actual constant that makes it go through this point, and then we can answer the question and move along. So the reason why this worked out kind of nicely, even though you probably wouldn't expect it to, when you square this, pi over 2 times pi over 2 would be pi squared over 4. So pi squared divided by pi squared, the pi's just go away. 36 divided by 4 becomes 9. Use the unit circle to get 1 for this. So 9 plus 1 plus c is supposed to be 10. So in other words, c is 0. So in other words, here is the function that has the correct derivative, and it goes through this point. It's meeting the 2 requirements it's supposed to have. And now finally, if I've got the function f of x, I can find any point just by plugging in that x value. So if I plug in pi over 6 here, I would get pi squared over 36. 36 over pi squared times pi squared over 36. This just becomes 1 plus the sine of pi over 6, which is 1/2. So in the end, you should get 1.5, or 3 over 2. Okay, Landon, was there something more specific there, or was that got you past what you needed?
Yes.
That's enough?
Yeah.
Okay. Is anybody else going to ask about 6? Want to ask while it's still up? So again, the only thing that the process is exactly the same as the first 5 and probably the next few. It just looks a little scarier because of these numbers, but antiderivative, the first step is probably the hardest. Plugging in 2 numbers and solving for c is really just arithmetic. Plugging that c value in and then plugging in this value, which is once again arithmetic. It's really this first step of antiderivative should be the hardest part for you. Okay, so I would like you to please pick up wherever you left off on that circuit on 65. And again, I'm going to ask that you use the rest of the first half of class on that. So I think that'll probably be enough time to finish, but we will evaluate at the halfway point. If nobody's finished at the halfway point, then I'm not going to ask you to do it for homework. But if most people are finished at halfway point in class, then you might need to do a couple more to get caught up. So while you're doing that, I am going to come around and start checking some of your semester exam review stuff. Again, since I was out on Thursday last week because they made me go to that math training, I've just checked less of y'all's work than I have of other people's other classes, so I need to play catch up on that a little bit to help you get the feedback that you need. So I'm going to start with the people that I never checked off as being fully finished with 61, and then I will start checking everybody's 63. I don't have you checked off as 61. Okay. Correct. First step's good. Okay, so that's where you're falling apart. If you're doing the limit of a function plugged into another function, you do the limit of the inside, you get a number, you said 0, that's correct. Then you plug it into the outer function, but not the limit.
Oh.
So your answer comes from h of 0,
Okay. H is 0.
which is just asking about the point. Negative. Yeah. So it's not a hard process, it's just one that you never practice. So that's why you might need to review it in case it shows up. Okay, so that was it for there, and that was -5. Okay, on that one I'm getting -6, so maybe we're just estimating it's a little different.
Oh, yeah.
Yeah, so make that -6, and then now I've checked you off. Okay, you have your 61. So you still need to finish these last questions. And then right here, you need to be careful about this notation. 7 was the correct answer because it was 3 plus 4. But you can say 3 plus 4. F of 3 means something totally different. That would mean the point on F when X is 3, which might not be certain. So don't say F of 3 plus G of 4, just say 3 plus 4. So but you'll need to finish that. Here, this is, I get what you're saying here, but you probably want to say something about Y values. It guarantees all the Y values.
So
61. Just checking that. That's been fixed. Okay, you fixed this one, so I erased that. This one, how'd you get 3 here?
Look, one up in 0.
It sounds like you did one thing wrong the first time, but something different wrong the second time. When you're doing the limit of a function plugged into another function like this, you need to do just the limit of the inside. So what's the limit of g of x if x approaches negative 2? I think that's 0. Okay. So that's 0. That gets plugged into the outer function. So h of 0 should give you your answer.
And then you do that.
Yes.
So negative.
Right, so negative. So it has nothing to, it's only limit of the inside and then it's point of the outside. So that process is not. This one I got 2 over 3.
Yeah, that's what it is.
Oh, okay, okay, I can't see that. Okay, so I'll check that off.
And then I would touch on this one right here, the circuit.
Okay.
I haven't finished yet, but I got like a weird number. I have 1 plus 3 pi over 32 plus 3, and I don't think that's right.
Let me look. Let me try it up here and then we'll compare. Which blocks was it? 3 over 2. Okay, is that what you got for the general solution? Okay. Tangent at 0. Okay, and then pi over 4 would be 1 plus squared over 16 plus 3. Okay. Was this kind of what your mess looked like at the end? Okay.
Yeah.
So, I mean, I think it's fine. It's just a matter of figuring out which one of these it simplifies to. So, something with pi. It's probably this one. And since this is one big fraction, if it is, they maybe got a common denominator. So, let me bump this up and multiply these. This would be 3 pi squared over 32. Okay, so I'm just bumping that up a little bit. So this is like 32 over 32. This would be like 96 over 32. I think that's 3. So now they're all over 32. These two add up to 128, I think. And yeah, that's how they wrote it.
Alright, thank you.
So your calculus was good. It's just, it was still kind of a mess to simplify. But now again, the good news is if that was an FRQ, you never have to do arithmetic on the FRQ, so you could just circle and be done. And as a multiple choice, you at least have to, you would see like, I've got this and none of them look like that, so what could I do to try to fix it? So, okay, you got your 61. You finish checking. Looks like I already did this some. So this one, I think we're kind of close, but not the same. So you didn't write everything here. What do you think the limit of g of x is as x approaches -2? Okay, so put that under there. And minus. Okay, Okay, what do you think the limit of x approaches negative 2 of x? Okay. Negative 1 minus, there you go, negative 6. So that looks fine. Here, this one looks like you're doing L'Hopital's rule, because the derivative of this is this. But the derivative of this, you've got the chain rule in here, but the derivative of cosine something would be negative sine of something. So you need a negative and sine 2 theta. And then plug that in, you should get a different number. Now, for this one, you could do this 2 different ways, but if you can do L'Hopital's rule on this one, you could do L'Hopital's rule on that one. So, finish this one. Make sure you get an answer of 1/2. And if you don't get 1/2, ask me so I can help. And then try L'Hopital's rule on the other one. Right. You got 61, let me check.
Can you already check my 61?
I might have given you some feedback, but I didn't check off that it was finished. Okay, I'll come back to you. I need to finish checking your 61. Maintenance, you have your 61 minute check or finished or?
Yeah.
What you get on the other one? Okay, well, what's 1 divided by 0? There you go. Now I've got you marked down as finished. Harper 61. That was one time. Because just like what you're saying here, limits and points have nothing to do with each other. So that point, yeah, so it's negative 3. Okay, so that's fixed. Okay. That's fine. I think it's this all looks good, except for right here. This is just that easy bad math to get in. Mathematically, it doesn't make sense to take the limit of nothing. Like you have to say what you're taking the limit of. So make sure you just always write the function. So, but otherwise, everything else is fixed. Cool. Thank you.
I got well, I did through the weird. The answer is 28 minus 3 pi squared. But the arithmetic side squared. It was like, I got to the point where it's like 3 over 2. So this pi squared over 16 plus 3. And then like,
So imagine pulling this 2 out front.
3 over 2 times pi squared over 16 plus 3. And that all simplifies out
So
of
the
that.
answer to that is 2 times
It didn't make
whatever
sense.
antiderivative of 1 over 1 plus x squared is. What can you take the derivative of that? Almost, but notice if you take the derivative of this, you get 1 over this like you want, but then because of chain rule, you get a 2x that you don't want. So the 2 you actually do, but there's no way for you to get rid of the x. That's why that's not. That, it's this. If you have that memorized. So it's just 2 inverse tangent of x, and you're done. So I think this one probably shows up later, so try to be on the lookout for that. Here. Okay, Caroline, you're 61. I don't have you checked off yet.
Is that the
That's the first one. That's on the 60.
So I remember, I think, because we were passing it back, you didn't pass it back, but I told you I was trying to
I haven't collected these from you. These are the semester exam review pages. I haven't actually turned any of those in. Okay, you need, well,
Isn't it this?
yes, those are right. Okay, let me have those pamphlets for a minute so I can check them and tell you if I disagree with them. I'll get them all here. Arthur, you need to put your phone away. Okay. Looks like a phone. Yeah. Yeah, no, I can. So, kind of, yeah, but with chain rules. So if you think of all of this to the 1/2, do power rule, bring the power down, it's just gonna make a 1/2. You have to lower the power by 1, so if it was 1/2 and you lowered the power by 1, which means it's moving to its little denominator. So you're gonna have the square root of 3x plus 13 in that smaller denominator. Okay, and then because of chain rule, it would be times 3 right there. Now down here, because all of this is in the denominator, so when you take its derivative, it's all gonna be in the denominator. Okay, so I'm sorry, it'll be in the numerator of the small denominator. Okay, and the derivative of x plus 4 is not x. It's just 1. So now that you've taken the derivative, it was indeterminate forms, you do L'Hopital's rule, derivative of your numerator, derivative of your denominator becomes your denominator. Now plug in -4 into what's left over and see what you come up with.
2 over 3.
Yep.
Are we turning this in?
Just leave it out. I'll come around and check to make sure, because I can't remember if that was your only thing. So I'm checking it here so that way I know what you have points. Okay, I'm gonna ask about 10 more minutes on the circuit. So I'm actually gonna give you about 5 more minutes, and then I'll offer to help out with 1 or 2 to kind of close off and help you find a good stopping place on the circuit for today.
Oh, you're in degree.
There's only 2 that I just removed. Okay, so one's number 13, so you have here about 13 because we just talked about that. And then number 22, you did L'Hopital rule. Okay, I think you're close, but I think the mistake you made, did you see how this was in the denominator? So if you just did this derivative, you bring the power down, lower the power by 1, and you did that. Here's the 1/2, you lowered the power by 1. Okay. Okay, that looks fine. Negative. Okay, I'm with you here. I think you did the derivative fine, but then you should have plugged in -4. 3 times -4 is not 12. It's -12. So that makes this 1 times 3 times 1/2. So what's 1 divided by 3 over 2? There you go. So it was just an arithmetic mistake. You plugged in 12 and it should have been -12. Okay, I can check you off as being finished now. Okay, what's that? Can I finish checking that? I can't remember what else you messed with. That's good. That's good. Okay, that one's done now. Okay, before we call it good enough on the circuit practice today and thinking about antiderivatives and solving for C and all that kind of stuff, let me try to help you on the next one you got stuck on, so that next time you can review that and hit the ground running a little bit better. So y'all asked about number 6 at the start of class. Did anybody get stuck on number 7? Okay, there is an answer of 3 over 2, right? Oh, here it is. Okay, so this was number 7. Okay, did anybody get stuck on number 7? I worked it out for somebody else earlier, but I can rework it out if you need me to.
Can you work it out?
Yes. Okay, so if going over number 7 would benefit you, then please follow along with me here. Okay, so again, you are totally free to disagree with me once you see all of it, but I actually think integration and antiderivatives is easier than derivatives just because there's less stuff. Derivatives, you have to learn power rule, you have to learn how to use your calculator, you have to learn to memorize some. You have to learn product rule, you have to learn quotient rule, and you have to learn chain rule. And implicit, if you call implicit a different type. But with integration, it's undoing power rule, like this one. So you can always just raise the power by 1 and divide by the new power. That's one of 4 type of integrations you've got to be able to do for this class. Another one is undoing some that you have memorized. So there's not much you can do if you don't have the correct ones memorized. So on that second page of your semester exam review, I tried to remind you of those. So again, please don't wait till the night before to try to sink all that in your brain. Make small efforts every day. The derivative of tangent is what gives you secant squared. And then the only other 2 are using a calculator, which you've seen and you'll practice a million times more, and a process called U substitution, which we will get to later on. So, okay, plus there could be a c, there could be a constant, because the derivative of a constant is 0, and so they're not going to put plus 0, they're just not going to write that. So if the question said find the general solution, you would actually be done. General solutions have plus c. If it's a particular solution, they have to give you more information, like it goes to the point 0, 3. So when y is 0, x is 3. When y is 0, when x is 0, y is 3. I should probably know that. Tangent at 0, that's a unit circle question. Plug in 0 here, this goes to 0. So all of that to figure out that c is 3. So it's not hard, it just takes a couple steps. Now you can go back up here and say, I don't know, or it's no longer a generic constant, it's actually 3. 3 is the number that has to be there to make sure it goes through this point. And then to answer the question, so here's the particular solution. So again, most of the time that's all you need. But to move forward in the circuit, they want us to plug in pi over 4. So tangent at pi over 4 is 1. I get that from the unit circle. Sine and cosine are the same. Sine divided by cosine for tangent. Plug in pi over 4 here. Pi over 4 squared would be pi squared over 16. Times that by the 3 over 2 there. And then add 3. And you may have overheard me talking about this with somebody else a minute ago, but again, in an FRQ, not just me, but College Board does not make you simplify arithmetic on FRQs. It would be a mistake to waste your time and to hope that you can simplify this by hand on an FRQ. Just circle it and be done. Obviously, we have to practice simplifying because we also deal with multiple choice, and in this case, none of the answers look like this. So the last hurdle is trying to make this look different, and so I'm going to bump it up here so I have room to simplify. But this would be 3 pi squared over 32 when I multiply those. Okay, and then I scanned the other answers. I tried to pick out the answer that I thought looked closest to this one to give myself a hint on how they might want me to simplify it, the same way that you might do on a multiple choice question. So what they did is they changed these to common denominators. So instead of calling this 1, they're calling it 32 over 32. Instead of calling this 3, they're calling it 96 over 32, same as 3. And if you get them all to have a common denominator of 32, you can push all of those together, combine your like terms. 96 plus 32 would be 128. And then you've got a plus 3 pi squared, and then that's the answer they were getting you to look for. So the arithmetic, getting a common denominator, again, I don't do that automatically, but if I'm confident in my answer and none of the answers look like that, then that's a good chance that's what it was. Okay, so again, it doesn't look like most people were able to finish the circuit today, so I will give you more class time the first half of class on Thursday. You do not have to worry about doing this for homework, okay? Okay, so if you haven't yet, I would like you to refocus on your semester exam reviews. So remember, page 60 was your blank piece of paper where you're slowly writing examples, formulas, definitions, whatever it is that you feel like you need to relearn, restudy. So you're putting all that in one place. So 61 was the first page. And again, I've just been doing one page at a time, so it's all been very manageable as long as you've been keeping up with what I've asked. But the first page was focused mainly on limits. The second page of the semester exam review was mostly focused on derivatives, chain rule, product rule, quotient rule, stuff like that. The third one that you did last class was mostly focused on function analysis. So first derivative test, second derivative test, concave up, concave down, increasing segments, decreasing segments, all the stuff that was on your last test. So most of the time students feel like they need to review that less because it has been more recent, so hopefully that's the case for you as well. And then today's focus is on, well, I don't have it, here we go. Riemann sums and trapezoidal sums on the front page, so making sure you know what the purpose of those are and practicing a couple of each. One left Riemann sum, one right Riemann sum, one midpoint Riemann sum, and one trapezoidal sum. And then that's pretty much the front page. And then the back page has a couple more practice questions on some of the topics I feel like I did not give you enough practice on, or question types that were getting lots of questions from y'all and from my other classes. So the back page is 3 questions using tangent line approximations, 3 questions on related rates, 3 practice questions on implicit, and 3 questions making sure you understand the relationship between position, velocity, and acceleration. So that is the additional practice I would like you to get in today. So what I need you to do is work on assignment 67, please, the one you picked up on the way in today. You do not have to do the circuit for homework, but if you don't finish 67 in class, you do need to do that for homework. So I need to be able to check that at the start of next class. And I will be going around trying to help still and check off the last of the grades for the first couple. This is fixed. On this one, you did L'Hopital's rule, which you could. The derivative of your numerator is correct. The derivative of your denominator is missing something. The derivative of cosine something is negative sine something, but you missed the chain rule. You needed times 2 because of the derivative of one side. So when you put in a 2 there, your answer goes from being 1 to 1/2, which is the correct answer. So squeeze the 2 in there for your derivative. You just forgot about chain rule on that side. And then this one, okay, so looks like you did L'Hopital's rule again. So derivative of this is 1, that looks good. It looks like you did the derivative of this correctly. What's the derivative of -1? Nothing. So you didn't take the derivative of that part, so just erase that. Or make it positive. Since you're multiplying by -1, that's going to make this positive. Okay, and then the last thing is, this 3/2, I think is all of this word, but you forgot that all of this was under 1. So what's 1 divided by 3/2? Okay, how would that simplify those? Dividing by 3/2 is the same as multiplying by height. I'm saying, like, you think of these as two fractions. Fraction divided by a fraction. How do you divide fractions?
Multiply by the, like a flip.
Right. So 1 divided by 3/2 is the same thing as 1 times 2/3. So that's why you're on 2/2. So the habit you need to make, you wrote those down right, but then you start doing work and you lost this 1 over, so you had no chance of remembering to flip that up. So just make sure that you write that on that notes. It's a pain. Okay. You would fix both those. Okay, 63. Yeah. Okay. I'd rather you find that out now. I'll bring it back.
Johnson, number 3 on number 67, is that meant to be a 2 plus 3 on the table? Make it equals.
Sorry, you have to show me. I don't know which one you're talking about.
This thing, 3 equal,
Yeah, 300. So, yeah, so you're gonna have to do 1, 2, 3. You gotta do the 3 as you know, but yeah, they're not always equal. true, but it could also be negative infinity, positive infinity. Okay, down here, this one you should be able to do without a calculator.
Okay.
If you have these memorized. So that would be 5 secant x tangent x. That's the one your calculator can't do. Your calculator can do a derivative if you only care about it at a specific point.
I think I tried to do math, right, and then for the,
Okay, it is there. I don't. Okay,
if this works, this means it does not work. Last night.
well, since you're using the trig function, you have to be in radian mode, which you are. Okay, I think all it is it doesn't like how you're typing this in.
Okay.
So just go ahead and multiply these. 5 times this would be like that.
Oh, okay.
It just doesn't know what to do with 5. It's not doing 5 times, even though I know that's what you meant.
Okay.
So, yeah.
Okay.
So there's your answer for that. And that finishes the first page. Okay, and then on the back.
This one I didn't really know.
Okay, so these two, I want you to think about again, but I'll help you next time. Related rates are always if it's a function of time, or if you're taking the derivative with respect to time. There's always a time element with related rates.
Okay.
This one, your answer's right here, but this looks like, what is this?
It's wait.
Yeah, exactly. You gotta look at the question. You can't say m over m.
It's meters per minute.
Yeah, so put m over min.
Okay.
It's not meters per meters.
Okay.
And then on this one, the problem that you had is that you're doing Pythagorean theorem. Pythagorean theorem only works on right triangles, and no one said that that's a right triangle. So since it was about how area of a triangle changes, you should have started off with a equals 1/2 base of height. Then do the derivative, which is product rule like you did up here.
Okay.
And then you have the 4 numbers to plug in. And then that'll be your final answer.
prime at -2. So h prime is like the slope then. Okay, so here's x as it gets close to -2 from the left and from the right. What does it look like the slope is there? Because you need the derivative. It's 0, yeah. Because this looks like this is probably going to about 8, and this is going to about 8, so it's probably hitting 8 in turning direction. So the slope's probably 0, and you put a 5 there. So that's what threw that off. Right here, this looks good. What's g prime of 1? Yes. See, you put, it looked like you're thinking about the point, but if it's derivative, you need to be thinking about slope. So that's what threw that off. Related rates are a function of time, or when you take the derivative with respect to time. Yes, both the same. And down here, you set this up correctly, but I don't think you plugged the numbers in the right spots. So so fix that for me before next class. Alright, just let me look at what you got. You got 63. You forgot it? Okay. you have to, if you want derivative, sometimes you have to use that as slope. You need to kind of like rise up the way. So you could call that -1 or -3. So, well, h prime says the slope of h at face value. So at -2, h the value. Okay, look at these values. As you get closer to 2 from the left, these look like they're getting closer to what? Okay, and from the right, they look like they're approaching. So if it's going to 8 on the left, or if it's going down to 8 on the left, and then up after 8, then it's got a slope of 0 at the bottom, because it's changing directions. So, that ended up being correct, so I don't know. Let's guess that, okay, but you got to look at that. So try this one again, and down here, correct formula, you did the derivative correctly, but I think you may not have plugged some of these numbers in the right spots to get the correct answer. So try those with the next spot, please. Okay, yours. So infinite limits, it could be this or it could be that, so make sure you know it's both. For these question types, you should be applying horizontal asymptote rules. So if the degrees are equal, leading coefficient over leading coefficient, degree of the denominator's bigger, it's 0, but if the degree of the numerator's bigger, it's or does not exist. It could be infinity or negative infinity, or does not exist. This one should be the time nonetheless, so make sure you don't memorize that wrong. That was fine. This was just asking you to explain how you made these. So like, this one you didn't put an x squared, or an x prime, or a y prime, but how come? Right, so you gotta think about this. If you're taking the derivative of x with respect to x, you don't need it. If you're taking the derivative of x with respect to y, you need an x prime. If you're taking the derivative of y with respect to x, you need a y prime. Y with respect to y. So you just need to say something about that. She's working on 24 and I think 25 also, so y'all might compare on that. This one is also time. The function is a function of time, or you're taking the derivative with respect to time. Related rates, this one looks good. Right here, this is the right formula, but that's not the derivative. You have to do product rule, just like these product rules, because it's b times h. And that's why they gave you 4 numbers, and you only plugged in 2, but there was actually 4. Okay, so please try that again before Thursday. Yeah. Okay, so there's only one way to do this question. So these 3, well, there's only one way to do this one too. You should always try direct substitution. It's the quickest and easiest and what you're supposed to do. These 2, you did direct substitution. You got an indeterminate form. So you can deal with indeterminate form with factoring if you want. You can deal with it with conjugates if you want. Or you could have done L'Hopital's rule. Down here, this one, the only way you're going to do that one is L'Hopital's rule. So L'Hopital's rule says negative pi over 4. Okay, so you still have to try direct substitution, but if you get this or this, you can try to factor it like you did on the first one. You can try conjugates if you wanted to, but neither of those are going to get you anywhere. So L'Hopital's rule is actually preferred by most people, just because it's a lot less algebra. So you're going to, it's not the quotient rule. Just take the derivative of the numerator, make it your numerator. Take the derivative of your denominator, make it your denominator. So cosine something would be negative sine something.
And then make sure you get chain rule times 2. Now that you've taken the derivative of the numerator, manage your numerator, taken the derivative of your denominator, manage your denominator. Now you can try to plug it in and see if it's any better. So you get square root of 2 times the cosine of this, you get square root of 2 over 2, which really just becomes 2 over 2, which is 1. Plug in negative pi over 4 here. Times that by 2 would be negative pi over 2. Sine of negative pi over 2 is negative 1, so that becomes positive 2, so you should end up with a half. So, again, most of the time, like, I'd say most people probably did at least one of these two with L'Hopital's rule, but you have to know L'Hopital's rule, because sometimes those tricks up. So I'm trying to just emphasize that when you need a derivative, sometimes you need to think about slope, and you have somewhere to slope. So go ahead and take the derivative of f, because you're going to need that. This is asking us to estimate. So, how do you take the derivative of f times c? So let's write out what that would be over to the side.
Oh, okay.
That's chain rule, that's quotient rule. Yeah. Alright. But some of them will be like f, and some will be f prime. So f is referring to points, whereas f prime you would need to be thinking about slopes. So whether you get that derivative from a function, the slope from the graph, and estimating rise over run, or looking at a table and estimating rise over run.
And then for this one, what would this translate to be?
Okay, so the 1/2 is just lay out front, parentheses. And then how do you take the derivative of b times h? What's another word for time? What's another word? Starts with a b.
Product?
There you go. So you do the product.
Yeah, I mean, so basically just product quotient rules.
Yeah.
Alright, thank you.
Yeah, I do. On this one, when you said there's not an actual point, it's really more about if there's a hole there. Because, like, here's what you're saying, even if there is a point there, if it's like not in the right spot. Okay, and then down here, this is the final process, but this is x plus 4 times all this, so you can't just do the plus 4 with the plus 5. What you should have done from here is if you factor out a 3, it's 3 times x plus 4, and then the x plus 4 is cancel, and then you can plug it into the rest of the mess. It should give you, I believe it's 2 over 3. So I'm gonna mark you down as we have to make sure that you get it.
Wait, who's our varsity team for that?
I think next week.
Ooh, Colonia. You don't get school visit?
I don't think so.
You're on the team?
I haven't even done it in my
Oh. Is it not long? Yeah, as long as it's not that end, that's fine.
actually so much.
What do you do on Twitter? No, I can't see it. Why? So I thought I didn't do it before.
So funny.
So bad. I don't want to know anyway. Well, alright. Yeah, but we had to do John every day for fun. Yeah, I'm not your beef.
It's not beef with me.
You said I praise the table.
I do.
Why?
It's weird.
So.
I need to estimate the area.
So Townsend, what does MBT tell you specifically?
I'm sorry.
What does mean value function tell you specifically? I know how to do it, but like, what does it tell you?
It's continuous from A to B and differentiable from A to B. That the instantaneous rate of change, aka the derivative, has to be equal to the average rate of change, aka slope, at least once. It'll be 50 points on multiple choice on FRQ. I don't know. Correct. 50 points in the grade. Yeah. Okay, so we're getting close to out of time here. I'm sorry I got held up. Teacher caught me outside of the classroom for a second. But if you did, just to be clear, you do not have to work further on the circuit unless you just think they're fun and you want to work on them. I will give you more time on that next class. That's fine. But you need to finish up 67, the 4th page of the semester exam review for homework. If you did not get to that, has to be done before I see you on Thursday so that you're not falling behind. Somebody asked a question, and again, I say the same things in so many classes that I forget sometimes. But your semester exam will go in as a 50-point test, period, end of statement. You have to take the 50-point grade. But it also can count as a test replacement grade. Have I mentioned that in here? I have?
Oh, well, I think that's like in the syllabus.
Oh, okay, great. So the grade replacement is only there to help you. So if your lowest test grade was 85 and you make an 80 on the final, you have to take the 80 as the test grade, but I wouldn't change one of your past tests to be lower. But if your lowest test grade was an 85 and you make a 90 on the final, you'll get a 90 on the semester exam test, and I can change that low test grade up to a 90%. So depending on if you just had one lower test grade, your grade could catapult up quite a bit, but just depends. Yeah.
So it'll go in as its own grade?
Yes.
Also change a grade?
It will also do a grade replacement if it helps you.
Okay.
Yep. So in a way, it could almost count as 2 test grades if you do well on it. So just trying to give you a little extra incentive to finish the semester strong. So anyway, make sure you have those 4 parts of the semester exam review done for when I see you on Thursday. And I think our semester exam is Thursday of next week, if I remember correctly. But it is in your student announcements.